All right, so we're going to continue looking at right triangle trig, getting into inverse trig. Okay, and this first part you already have in your notes from yesterday. Basically, it gives you the two different scenarios when you're solving a right triangle. Okay, in addition to the 90-degree angle, I either need to give you another angle and another side, or I need to give you both sides. Why can't I give you both angles? Why wouldn't that help if I said, all right, I have a triangle, it's got a 30 in it, it's got a 60, tell me how big the sides are. Yep?
Because there's similar triangles, so the sides can be
Right. That's why angle-angle is not a congruence postulate in geometry. Angle-angle can't be used to prove congruence. It can only prove that things are similar. So with similar triangles, the sides could be anything. It's like if I said I have an equilateral triangle. Angles are 60, 60, 60. Tell me how long the sides are. Could be anything, right? We don't know. So that's why I always have to give you at least one side, so you have a point for the scale of the triangle. Okay. And the two theorems we'll use are Pythagorean Theorem, and we'll keep in mind that all the angles have to add up to 180. All right, so the three trig functions that we're going to use when we're solving a right triangle are either sine, cosine, or tangent. Okay, we're not going to use secant, cosecant, or cotangent. Not because they don't work, but because we don't have buttons for them on the calculator, and it's harder to use stuff we don't have buttons for. All right, so we're going to stick with those three. And now, how do you figure out which one you want to use? Well, in the problems we're going to start with, you're going to have a side that you want to know, and you're going to have a side that they give you. Okay? So out of the two sides that I just said, you have to figure out the names of them. Okay? So let's say, for example, they give you the opposite side, and you want to know the adjacent side. Well, out of these three trig functions, you have to figure out which one has opposite and adjacent. So this would be a problem with tangent. All right? So you look at the side you know, you look at the side you want to know, and then figure out which of the three trig functions you need to use. So we're going to start out with the type that they give you a side and an angle, and then we'll go to the type where they give you two sides, and then that gets into a whole another thing, that's inverse trig. All right. So they're telling us that one angle of a right triangle is 37 degrees. The hypotenuse has a length of 8. Now, they didn't tell us which acute angle that was. They just said one of the angles is 37. You can call it alpha or beta. Okay, no matter what you call it, you're still going to get all the same 6 answers as somebody else. Okay, you might call something alpha and someone else might call it beta, but you're still going to get the same numerical answers. All right, so the first thing we usually do is make a sketch, especially if you can't visualize everything in your head. So make our sketch. Keep in mind the sketch is usually never to scale. All right, so hypotenuse is 8, and I'm going to put the 37 right there. Okay, so I'm going to label my sides. This is A, B, and that's C. Okay, I put it in parentheses so you didn't think I was like 8C. I'm just letting you know it's that side C. And now, because of the way I labeled the sides, I've given the 37 a certain name. Okay, what's the name of the angle that's 37? Yep, I've now forced this to be alpha, and the angle at the top, beta. All right, so there's our diagram. Okay, the other thing I usually set up when we solve one of these problems, which I could spend some time and make another little picture for that would speed things up, is I make a chart with the 3 sides in one column and the 3 angles in the other column. So we have to find all of these. This one is always the right angle, so there's nothing to find for that one. Okay, I'm going to fill in what else we know. Okay, C is 8, and alpha is 37. So I put boxes around the 3 things that we need to find.
I mean, can't you just find beta by adding 37 and 90 and subtracting from 180?
Yeah, you can add 37 and 90 and subtract them from 180, and that'll give you beta. What's an even easier way to find beta? You don't even need to do that much work. Just subtract 37 from 90. All right, you don't even have to deal with the number as big as 180. Okay, so just 90 minus 37, and we get 53 degrees. So even though we can find it easily, it's still something we had to find. That's why I put a box around it. So any questions on that? All right, so now we have to find A and B. I can't use the Pythagorean Theorem because I'm missing two sides. Okay, I don't have enough information to fill in. So let's find A. So in order to find A, I need to use two pieces of information. I need to use a side and an angle. Well, right now, that's the only side I have. So I have to use that. But I have two angles. I have a choice. I could use alpha or beta. Which one do you think I should use?
Alpha,
Why?
because it opens up to A.
Well, the position of it, where it is, doesn't really matter. Because with using the three trig functions, things could be in any position, and we could still figure it out. But there is a reason. I do like the idea of using alpha over beta. Anybody? Well, we know beta too, right? We know both of them. Anyone think? Yeah?
Because it's the angle they gave us.
And why would it be better to use the one they give you?
Because if you did your math wrong and you like, say it was supposed to be like 52, and then you do like all of the other calculations based off of the wrong thing or everything as well.
Yeah. So the idea is we're going to avoid using things we calculate to find other things, for exactly what Amanda just said. If you make a mistake doing something and you use it, then everything else is wrong. That's what I was getting at a little bit earlier when we went over one of the homework problems or something. All right, so A is what I want to find. 8 and the 37 were what we're given. Okay, we're going to use the 8 and the 37 to find A, and we'll use it in a minute to find B. All right, so now, from the perspective of the 37, what's the name of side A? That's opposite. So opposite is what I want to know. And what's the name of side C? Hypotenuse. That's what I already know. So what trig function has opposite and hypotenuse? Sine. Okay, so we're going to write, and this is to find A. Sine of 37 equals opposite over hypotenuse. Okay, how long is the opposite side? No, not x. A. Yeah, we called it A. We could have called it x, but we didn't. So opposite, and then the hypotenuse is 8. Okay, and now how do we get A by itself? Yep, multiply both sides by 8. 8. And we get A equals 8 sine 37. Okay, we'll type that in and we'll just round it off to 2 decimal places. All right. So before I type it in, what do I have to fix on my calculator? Yeah, I'm in radians. Okay, you can do right triangle trig in degrees. Nothing changes except the mode on the calculator. But we're doing degrees. So 8 sine 37 gives me about 4.81 units. Okay, that's the length of side A. Now I've got A and I've got C. So technically I could use the Pythagorean Theorem. Right? I'm only missing B. But why am I going to stay away from the Pythagorean Theorem? At least to find B. Maybe I could use it when I'm done if I want to check my answer.
A is a rounded answer.
Okay, A is rounded off.
And you found it.
And I found it, so it could even be wrong. Okay, so if A is wrong and I use it, then B is wrong. So let's find B the same way we found A. That's what I want to find. That's the angle I was given. That's the side I was given. Okay, so this time focus on everything that's in green. Well, I've already labeled the hypotenuse. What's side B?
Adjacent.
It's adjacent. And now I want to know adjacent. I already have hypotenuse. What trig function has adjacent and hypotenuse? Cosine. finish up, we'll find C. I'm sorry, B. Cosine of 37 equals, how long is adjacent? B. And how long is the hypotenuse? 8. Solve it exactly the way you did the last one. Okay, 8 cosine 37. Okay, so let's see what we get. 8 cosine 37, 6.39. Right, so B is 6.39. And that's it. So now we solved the problem. What I could do if I had extra time is I can check it with Pythagorean Theorem. If I've done everything right, a squared plus b squared should equal c squared, or slightly off because I rounded. So what should a squared plus b squared come out to here? Should come out to 64. Let's check it. There's a squared plus b squared, and it comes out to 63.97. Okay, so it's not exact because of the rounding, but that confirms we probably did everything correct. Any questions on that type of problem? All right, let's try. All right, we can try one more where we were given a side and an angle, and then we'll move on to two sides. Okay. All right, where do I put the 20? It doesn't matter. So where do you want to put it, Amanda? The bottom. Okay. So there's the 20. Now that she put that there, the A does have to go somewhere special. Where does the A go? Nope, not on the bottom. Can you be more specific? I'm not sure what you mean by top. Yeah?
It goes off the angle, so it's the vertical line.
Yeah, it's the height. So A has to be the height of the triangle. And now if that's alpha, that's beta. If that's beta, that's B, that's C. So there's our diagram. All right, so I'll make my table. We've got A, B we got to find, and C we have to find. Okay. Alpha we already know is 20. Now beta we have to find it, but we can do it pretty easily as we're going, just setting up the table. How much is beta? 70. And now that we found it, we're going to forget about it because we don't want to use anything we find, just in case it's wrong. It's not wrong, but just in case something weird happened, you could still get credit for the other parts, even if you get one part wrong. That's the nice thing about right triangle trig. You can find everything separate for now. Okay? When we take away this right angle, that doesn't happen anymore. You have to use things you find to find other things. So unfortunately, it means if you make a mistake in one part, then a lot of it comes out wrong. All right, so we've got beta. And now we're going to use, what angle should I use to find B and C? I should use the 20. And I'm going to use the side that was given. And it doesn't matter which one you do first, because we're going to find them separate. Okay, so let's do C first. What trig function would I use to find C? Sine. And what would be the equation I set up? 12.3 over C. And now I wanted to do this because this is a case where the variable is in the bottom of the fraction. In the other problem, the variable was in the top. So I'm going to solve this one the long way, and then you'll probably see a shortcut. Okay. What can I do on both sides to get rid of the fraction? Yeah, we can multiply both sides by C. And now I have C sine 20 equals 12.3. But now I want to get C by itself, so how do we put the sine of 20 on the other side? Yeah, divide by sine 20. divide by sine 20. And you end up with C equals 12.3 over sine 20. Now, look at what we got for C, and look at what we started with. Does anybody see how to go from that right to that, skipping everything in between? Yeah, all that ends up happening every time when you have an equation like this, those two things switch places. You can go through it every time if you want, but that's all that's going to happen. So now anytime I have a variable in the bottom, that's how I'll solve it. Right? So if you gave me a problem like 5 equals 8 over x, I would just say x equals 8/5 without even really thinking about it. Just switch these two things. Okay? It doesn't work if you have something more complicated than that, but if you just have the number divided by a number, you can always do that basic idea. All right, so we've got C. Let's type it in. And the way we're going to type it in, we're not going to round off sine of 20 at all. In fact, I will never know what the sine of 20 is in this problem, okay, because I'm going to type it in like this. 12.3. And just have the calculator find the sine of 20, put it in the denominator, do the whole thing, give me the final answer. So it's 35.96. Okay, and the last thing we'll find is B. Go back to the angle and the side that we're given. So now you're focusing on everything that's in blue. What trig function would I use to find B? Tangent. Okay. And what would be the equation I would set up to do that? Tangent of what? Tangent of 20 equals 12.3 over B. So we've got the same situation as last time. So what is B? 12.3 over tangent of 20. Again, I'm just going to use that shortcut so I save all that stuff in the middle. Right, and now type that in. If you have your graphing calculator, you can just do that. I don't know, it saves you a few buttons maybe. And you get 33.79. Okay, so 33.79. So now if you wanted, you could check if a squared plus b squared equals c squared, but I'm going to hold off. Okay. So any questions on that type? All right, so the next type. We're going to look at what happens when you're given two sides. So this time it says the hypotenuse and a leg of a right triangle measure 12.7 and 6.1. Now they say respectively, so you should know which one is which just from the structure of the sentence. But even if they just said, you got two sides in a triangle, one of them's a hypotenuse, one of them is a leg. How do you know the 12.7 has to be a hypotenuse? Yeah?
The hypotenuse is always the largest side.
Yeah, it's got to be the larger one. Okay. Now, if they just told me you have these two sides in a triangle, these could both be legs. I don't know. But this time they did tell me one is a leg, one is a hypotenuse. All right, so let's make a sketch. It doesn't matter where you put the 6.1. And it doesn't matter where you put the 12.7. All right, and now I'm going to set this up. So we've got, let's see, I want to set it up so that happens. All right, so one thing we can find right away that we couldn't find right away before is what? What can I do this time that I wouldn't be happy with doing last time? Yep.
You can find them for the side by using the Pythagorean theorem.
Yeah. How come I'm okay with using the Pythagorean theorem this time, but I wasn't before?
Because you can use two of the sides.
Yeah, they gave me 2 of the sides. So everything I'm going to plug into the theorem is given. Okay, that's okay. Okay. We don't know alpha, and we don't know beta. So the thing you can't do is just add up one of the angles or subtract one of the angles from 90 this time, because you're missing both. All right, so let's do the Pythagorean theorem, and we'll find b. So 12.7 squared equals 6.1 squared plus b squared. So the way I'm going to do this is I'm not even going to round anything off. Okay? How do I put the 6.1 on the other side? Subtract it. So 12.7 squared minus 6.1 squared. And what is my last step? What, Tom? How do we get b by itself? Yeah, we've got b squared, so we got to take the square root. Okay. And it's the square root of all this stuff. Okay, the advantage of leaving it the way that I did is I didn't round anything off. It's not like I did 12.7, I squared it and then rounded it. Okay. I'm going to type all that in, and that's the only rounding I did in this problem was at the very last step. That's the best way to do the calculation so you don't get error from rounding. All right, so the square root of 12.7 squared, and also doing it this way, you don't need a calculator until the very last step. Okay, so you could set all that up and then you only need the calculator at the end. Okay, minus 6.1 squared, and we get 11.14. Now, another thing I should mention, which we kind of mentioned, is that the hypotenuse is always the biggest side, and that's always across from the biggest angle. Well, the smallest side is also across from the smallest angle. So before I even solve it, I already know which angle is going to be the smallest. Which angle is that? Alpha. Alpha will come out the smallest, and beta will be somewhere between alpha and 90. All right, let's find beta. Okay, and this was to find b. Okay, so to find beta, okay, I want to stick with the sides that I know. This side, that side. Okay, what's the name of 6.1 from the perspective of beta? It's adjacent. And how about the 12.7? Hypotenuse. Which trig function has those two? Cosine. So what would be my function? Yeah, cosine beta equals 6.1 over 12.7. What's different about this equation than like the one I had here where the variable was in the bottom, or the one here where the variable was in the top? This equation is different than both of those.
The exponents next to like the cosine.
The what?
The variable.
The variable. Yeah, almost think of it as it's inside cosine, right? That's the argument to the cosine function. It's the thing that you're plugging into cosine. Like if I had this, x is the argument. It's the thing I'm plugging into square root. So the problem with that is I need to get rid of cosine. Okay, how can I get rid of cosine? Does anyone know? I have a guess that people usually say, and if someone says that, I'll show you something. And even if nobody says it, I'm still going to show you something. Yeah?
Well, technically it's cosine negative 1 the inverse of cosine, like dividing by cosine.
Okay, so dividing by cosine, that's what I was hoping somebody would say. So the first thing you said and the second thing you said are not the same thing. This is a function. You can't do arithmetic with a function. Like you can't divide by cosine. Okay, a lot of people say that because they pretend like there's a dot there. There is no dot there. Right? So if you had something like this, and I asked you to solve it, how would you say, how to solve that? What do you do? Can somebody say it as a full sentence? I'm looking for a verb in there. Let's pretend square rooting isn't really a verb. So what am I doing to both sides? Well, it's already squared, so I agree with what you're saying. I'm just hoping somebody says it a little differently.
It's multiplying by itself.
We're not multiplying to solve this. When you're doing the square root on both sides, what are you doing? No, you're not dividing by a square root. You can't do that.
You're finding the root of that.
You're finding or you're taking. Right? You're taking the square root of what's on the left. You're taking the square root of what's on the right. Okay? You are not multiplying each side by square root. You can't multiply by a function. You can multiply by numbers and variables, but not functions. Okay? So the correct word here is take the square root of both sides. Same idea here. Okay? This is a function. So if you want to cancel out a function, you need another function, which is the opposite of it. Okay? And that's where inverse trig comes in. Okay, so to cancel out any function in math, you need another function that does the opposite. You cannot cancel a function with arithmetic. Like if you have square root, I don't care what you add, subtract, multiply, or divide, you can never cancel a square root with add, subtract, multiply, and divide. You need the squaring function to cancel square root. That's the only way. All right, so this is going to be kind of the inverse trig part. So inverse trig is the opposite of a regular trig function. Just like squaring and square roots are opposites. This is the symbol for them. It looks like sine with a -1. That -1 is not an exponent. Okay, which is a little tricky because that's normally where you write an exponent. And in fact, if you put any other number here other than a -1, it is an exponent. Okay, but when you have a -1 there, it means inverse sine. Okay, and then there's an older way of writing it. If you had, I guess, maybe a device that couldn't do exponents, you can write it as one of these three. Most of the time, I stick with what's on the left. Okay, but some textbooks, you might see this, means the same thing. Okay, so inverse trig are functions. Okay? They're things you are allowed to do or take on both sides of an equation. You don't do arithmetic with them. Okay? Any more that I could say, like if you had something like this, x squared equals 9, add the square root to both sides. If I did that, I would have this. That's what you get if you add square root to both sides. You can't. That doesn't make sense. All right? So no arithmetic with functions. So, looking back at this one, my goal here is to get rid of cosine. So what function cancels out cosine? Inverse cosine. So what am I going to do on both sides of this equation? I have to do it on both. You can't do arithmetic with functions. No, you can't multiply both sides by inverse cosine. Yep.
Take the inverse cosine of both sides.
You can do that. You can plug everything you see here into the inverse cosine function. Okay? That's not multiplication. It's just like taking the inverse cosine of what's on the left, and I'm going to plug all of that into the inverse cosine as well. Okay, so let's, if you do it on the left, what happens is those cancel. You get beta equals. And you know what? To show you it's not multiplication, try typing it in as multiplication. Watch what happens. If you press inverse cosine, right, and you try to do times 6.1 divided by 12.7, thinking, oh, it's multiplication, the calculator is just going to freak out. It just can't. It's like, what are you doing? So instead of doing it as multiplication, plug that number into the inverse cosine. Okay, but there is no multiplication happening in that problem at all. And now I get an answer of 61.29. So really, it's not that much harder to find an angle. You just have to use inverse trig. Now, if you were running out of time on a test, technically you could take that angle and subtract it from 90 to get alpha. But why would that be not the best idea? Yep. Because I found beta, and beta could be wrong. So I'm going to find alpha the same way I just found beta. I'm going to use this, and that. But notice what I just did. I circled a different angle. So now you walked over here. You're standing at a different spot. Your perspective changes. So that name no longer applies. What is the 6.1 now? Now it's opposite. The hypotenuse, that always stays the hypotenuse. So what trig function has opposite and hypotenuse? Sine. Well, we just used cosine last time. This time we're going to use sine. So we're going to find alpha. Sine of alpha equals, and it's the same thing, 6.1 over 12.7. All right, and now I have to get rid of the sine function. So how do I get rid of sine? Yeah, I'm going to use inverse sine. And how do I use it in this equation? What do I do? Right, we're going to take the inverse sine of what's on the left and take the inverse sine of what's on the right. Is there any multiplication happening here? No, that is not multiplication. So that's gone. And now just type in inverse sine of 6.1 over 12.7, which is almost what I typed in last time. Just change that.
That's the sine.
Yeah, inverse sine would be even better. 28.71. And if you check these two angles, make sure they add up to 90. Okay, I think they do. Yeah, they do. So we're good. So inverse trig is only used when you want to find an angle. If you only have to find sides, like we did in this problem, you will never have to use inverse trig. Inverse trig is only used to find angles. That's it. That's all it does. Okay, so any questions on that one? All right. So we talked about that. That's another one with two sides, but I think I'm going to skip over it because it would be exactly the same thing. I know I'm using inverse trig in this problem because I don't have any angles. I'm going to have to use inverse trig twice. And to get A, how could I do that? You could use Pythagorean Theorem because you're given everything else. All right. So before, we talked about unit circle trig, and I'm just going to go right to the definitions of it, where sine was y, cosine was x, and tangent was y over x. Well, that worked fine as long as you were on a circle of radius 1. But we can do this on a circle of any radius, and we get these definitions. Okay, let me show you why that happens. Let me draw this. And let me draw a unit circle. And let's pretend that that's a radius of 1. If I make a triangle, in that circle, and let's call that 1. Let's call that side x, and call that side y. And let's let the angle that we're looking at be from the perspective of where I just drew that arrow. Okay, so we're standing down in the lower left. If I asked you to find the sine of that angle, okay, forgetting unit circle trig, just use what we know right now. Sine is what divided by what? Yep.
Opposite over hypotenuse.
And what side is opposite this angle? Y. And divided by what's the hypotenuse? 1. So back when we did unit circle trig, this is why sine was equal to y. It was really just opposite over hypotenuse. I never told you that, but that's where it came from. Does anybody remember what letter cosine was? Cosine was x. Well, look at the picture. Cosine is adjacent over hypotenuse. What side is adjacent here? X. What side is the hypotenuse? 1. And that's why it's x divided by 1. Now, tangent, back when we did unit circle trig, was y over x. Opposite over adjacent. Again, I never told you that, but that's where all these definitions come from. And we always did it with a circle of radius 1. Well, now let's pretend that the radius isn't 1. Let's pretend that it's r. Okay, it's bigger than 1. Could be anything. If you go through the same formulas, let's do sine. Opposite is y over what's the hypotenuse now? And now we can write it as y over r. Cosine is adjacent over hypotenuse, x over r. And tangent is still opposite over adjacent. R has no effect on that. All right, so really, writing the trig functions in terms of a circle with a radius of r is just looking at opposite, adjacent, and hypotenuse a little differently. Okay? You're pretending like you have a coordinate. And you're using an x value, which is like your adjacent, and you're using a y value, which is like your opposite. And you're calling your hypotenuse r. But these definitions are exactly the same thing as we've been doing. This is just looking at it as a coordinate rather than as a triangle directly. Okay, because you don't need this diagram. Okay, I could just give you a coordinate. All right, so you could see a problem similar to this. Okay, the point 2, 3 is on the terminal side of an angle. Find the 6 trig functions of that coordinate. Well, really, all this means is you have a triangle like this. 2, 3. Here's theta. If you can do this problem with right triangle trig, then you can do it with just the coordinate 2, 3. You don't even need to think of it as a triangle. All you need to think of is the 6 formulas we just wrote down. Okay, so 2 is which letter in these formulas? 2 is the x. Okay, it's kind of like the adjacent side. And y is the, or I'm sorry, 3 is y. It's like the opposite. Now, what letter am I missing? I'm missing r. I'm missing the hypotenuse. And when we missed the hypotenuse last night, how did we solve for it? Pythagorean Theorem. So r, or the hypotenuse, is going to be the square root of how much? Amanda? Yeah, 13. So now you basically just created a triangle. We didn't draw it. We just have a coordinate and a radius. And now we can plug in the coordinate and the radius into all 6 formulas. So what would the sine be? Yeah, and the cosine?
2 square root of
13. And what about the tangent? 3 over 2. And now to find the other 3, you would just split those. It's just a slightly different way to look at right triangle trig, thinking of it as a coordinate, right? Rather than as a triangle. But you could make a triangle and then do it that way too. So it's really the same thing. So any questions on looking at it that way, as a coordinate rather than as drawing a picture. And notice in this problem, we didn't find the angles. That's what we were doing before. We actually would like use inverse sine here and find the angle. They didn't ask us to do that. Okay? We just had to find the trig functions. Any questions on how you do the 3 on the right? Okay. So now, let's actually solve for the angle in example 3. Okay? Any one of these trig functions is enough information to do that. Okay? I'm going to pick sine. Okay? And I'm going to use that equation to solve for the angle. So I have sine of theta equals 3 root 13 over 13. And how would I get theta by itself here? Yeah, take the inverse sine of both sides. So that is going to cancel that. And take the inverse sine right there. So type that in. Second, inverse sine, 3 root 13. Root would be nice. That's weird. Over 13. Okay, make sure you type it exactly the way I did. You gotta just be careful with pressing the arrow keys to get out of the square root when you do the division. And I get an angle of 56.31. If I were to sketch this problem out, that's the size of the angle that's right near the origin, between the x-axis and the hypotenuse, positive x-axis and hypotenuse. Now, that angle was in quadrant 1, okay? And that makes it acute. So if you're in quadrant 1, you pretty much can do what I just did every time. Set up this equation right here, and take the inverse sine of both sides. But if you're in quadrants 2, 3, and 4, it doesn't quite work that way. Okay, what we just did here would be the first step if you were in quadrants 2, 3, or 4. So let's pretend that I had the point instead of, what was the point, 2, 3? Let's do negative 2, 3. What quadrant would negative 2, 3 be in? Trevor? It'd be in the second quadrant. Negative 2, 3. That, I'm saying that that point is on the terminal side of an angle. There's my terminal side. And if they don't tell you where to draw it, you always put the initial side right there. So my question is now, how big is this angle? Well, think back to the diagram we just drew of the triangle that had a side of 2, and then a side of 3. We already know how big this angle is. We found this angle before. It was in quadrant 1. It looked more like this. But if you found it here, it's the same thing over here. It's just flipped into quadrant 2. So how big was this angle before? It was 56.31. And now, if this part is 56.31, how would you figure out how much this part is? Exactly. If you have an angle in quadrant 2, it's 180 minus your reference angle. Okay, and your reference angle is basically, it's the absolute value of inverse sine. So like, let's say somebody did this problem and they left this as a negative 2, because they said, oh, I went 2 to the left. You would have ended up with negative 56.31. All right, so what I do to even avoid having to deal with this absolute value of inverse sine, just think of your sides as always positive numbers. Even if one of them is going left or one of them is going down, think of the length as a positive number. It's like you're taking the absolute value. Right? So now what if I drew this triangle here? Right? And now the question I would be asking is, how big is that angle? What would you do? And assume you know this. This right here is 56.31. That's your reference angle. Nope, that'd be if you knew this part. If you knew this part on the outside, that would be 270 minus. Whoops, didn't want to do that. There we go. So how would you find an angle in quadrant 3? Yeah?
180 plus.
Yeah, it's 180 plus you have to add the reference angle. How much further you went. And then in quadrant 4, you could reason that one out. It's 360 minus the reference angle. So I just did -2, 3. Let's do -2, -3. Let's try this one. Okay, so what I usually do is I plot the point. Okay, that is on the terminal side of an angle. Draw your terminal side. Okay, draw your initial side. And now the question we're trying to figure out is how big is that angle? That's theta. Well, just by plotting my point, I know I'm in the third quadrant. And now I'm going to make a triangle using that coordinate as the tip of the triangle. Okay, and I'll do it in a different color. There's my triangle. The base is how many units long? 2. Think of it as like the absolute value. Okay, just pretend it's 2 units, even though it's left, and then how many units down? 3. So in this kind of triangle, we already know the hypotenuse. We've done it a couple times. Square root of 13. Now, find the inverse sine, and you don't need to worry about absolute value because you already made the sides positive. If you hadn't done that, then you would. Okay, but you already made the signs positive, the sides. Here's theta. We're going to find this angle right here. That's my reference angle. It's not the answer, but that's what I'm going to use to get the answer. So sine of theta equals, what's opposite the theta? 3, and I already made it positive, so I'm not going to have to worry about absolute value. And what's the hypotenuse? Yeah, it's hard to see. Square root 13. Now, normally I wouldn't like a square root in the bottom, but is this a final answer? No. This isn't even a final answer. This is just to find, I'm going to call it theta sub ref. Okay, it's just my reference angle. So how do I get rid of sine? Inverse sine of 3 divided by square root 13. So my reference angle, we already knew this, is 56.31. So now the answer, how do I get my answer for that angle that I drew in blue? 180 plus the reference angle. So it's 236.31. Okay, so there's a different formula for each quadrant, but the reference angle is always the same. If you're in quadrant 1, finding the reference angle is the whole problem. You don't have to do anything else. Just quadrants 2, 3, and 4. All right, so there was one slide left. We'll finish it up tomorrow, but it basically tells you where the trig functions are positive. Okay, I'm going to leave it on the board because there might be a problem in the homework where you need to reference this slide, but I'll keep it in the video so you can look at it. I think it would just be problem 57 or 61. But everything else you should be okay with. Okay, so we'll talk about this last slide tomorrow. If you get stuck on the homework problem with it, don't worry about it. Okay, so homework's on 361. Don't forget Thursday's a review day, so we'll go over anything we need to. And then our test will be on Friday.